Yeah, so just real quick, I'm representing the Office of Spent Fuel and High-Level Waste Disposition. My name is Jay Thomas. I'm the team lead for the Office of Storage and Transportation, and I've only been with DOE for about a week and a half. So I'm glad to be a part of this effort. Just a little bit about NE8. Basically is responsible for the disposition of commercial spent nuclear fuel. Underneath of it, supporting the mission is 3 offices: NE81, which is the Office of Disposal Research and Development; NE82, which is the Office of Storage and Transportation; and lastly, NE83, which is the Office of Consent-Based Siting. And as you've kind of learned already, we've got John Orchard, who's the Topic Area 6 Program Manager, and Jorge Narvaez, who's the IRP2 Federal Point of Contact. And so with that, I'll kick it back to John.
Okay, hi, I'm still here. Yeah, we NE8 has recently reorganized, and the storage and transportation topic area 6, or most of it, used to be in NE81, but now that that function, S&T, has moved to NE82, which used to be interim waste management, but now includes the storage and transportation topics. So that's why this topic area 6 is a bit of a hybrid. But I've been involved in the storage and transportation side of things for several years, so I was instrumental in putting the topics together, at least topics 1, 2, and 3 in the topic area 6. So that's why I'm here. We can probably go on from there. Who's next? Jorge?
Yeah, thanks, John. Good afternoon, everyone. My name is Jorge Narvaez. I'm a general engineer at the DOE NE Office of Storage and Transportation, and I'll be the point of contact for the IRP2 topic. Over.
Great. Okay, I think that's everyone. Did I miss anybody?
No, but this is John Orch again. I'll go back quickly. I think we got 5 topics in topic area 6, and the first 3 are storage and transportation. The 4th one is Jorge's area, and the 5th one is impact limiters, which maybe Jay, are you going to talk to that? That's what Erica was going to address, I thought, but I can field those questions if they come up too. So
yeah, yeah, I appreciate it if you could handle those. I'm probably not up to speed yet on answering those.
Okay, we can proceed.
Okay, thank you guys so much. Really appreciate you being here. Really appreciate your time and expertise. We're going to open it up now to questions. So first question, 3D imaging. Okay, let me start from the top. I have 2 questions regarding topic area 6, subtopic 1. Is the imaging intended for a specific stage of SNF handling, such as during transportation?
This is John Orchard. It's not specifically for transportation. In fact, that's probably an unlikely time to do it. It's during the storage period, and possibly because it might involve moving the canister to do the imaging, that might possibly be during the preparation for the transportation, where the canister is moved from its storage pad or module to the transportation cask, because we'll be handling the canister then, and that might be an opportune time to do some sort of 3D imaging. But some of the imaging, depending on what it is, could be done while the canister is static in its storage condition, either vertical or horizontal. And I think that's more what we had in mind, but we're just looking generally. There are some, new 3D imaging technologies developing, and they could be very useful for figuring out what's going on inside the canister, what's going on with the fuel and the fuel rods and the fuel assemblies. That's what we're looking for.
Thanks, John. So the second part of this question is, should we assume that the overpack is present during the imaging process?
Well, that's part of what it gets to. No, it would be nice if we could do it with the overpack present, but without it, the most likely time that it wouldn't be present is when it was being moved, when the canister was being moved, particularly to be put in a transportation cask. It's because of the high radiation levels from the canister, it's unlikely that we want to take it out of a shielded environment. But if the 3D imaging machinery devices were inside some sort of other shielded confinement environment, we could move the canister out of its overpack or module and into another shielded compartment to allow the 3D imaging to be performed there, or performed during the transition from the one shielded area to the other. So we're kind of open on how we do it, I guess, is what I would say.
Thanks, John. We have another question. At Urshagi Center for Energy Transition at USC, we are working on an innovative alternative for the Yucca Mountains, closely aligned with Area 5 SNF disposal research. However, in the meantime, this solution starkly reduces the transportation path. Please kindly let us know we should apply for which area we should apply for, or can we apply from multiple areas?
Well, first answer is you can apply for multiple areas. The second answer is I wasn't quite sure what the technology was. Or is it reducing the overpack, the transportation cask, or what are they trying to do? I missed that little bit in the question. Maybe you could repeat the question again.
Yeah, no problem at all. Vinesh, also feel free to unmute yourself if that's easier. Let me read it. It says, at USC, we're working on an innovative alternative for the Yucca Mountains, closely aligned with Area 5 SNF disposal research. However, in the meantime, this solution starkly reduces the transportation path.
Oh, the transportation path. Well, that'd certainly be interesting to see what that is. So I would certainly consider submitting it under topic area 6. I don't know what item under topic area 6 you'd submit it to. I'd need more information, but certainly that would be a good proposal for a topic area 6. Yes.
And I just wanted to kind of give some information that yes, you can submit to multiple topic areas, but you cannot submit the same proposal to more than one topic area. They need to be different if you're submitting multiple proposals.
Okay, I stand corrected. I guess it might be subjective of how different two proposals are.
Okay, I'm going to move on to the next question. For topic structural health monitoring of the SNF canister wall, area 6, topic 3, is NUP expecting the development of sensors that are bonded or bolted to the external wall of canisters for SHM purposes? And if the answer to question 1 is yes, does NUP expect the development of wireless sensors or the development of wired sensors tethered outside through the vent of the dry casket where the canisters are stored fine?
Should the sensors be attached to the outside of the canister, and is a wired connection acceptable as opposed to a wireless connection? And the second one, the wired connection, I think that's okay. It might be a little complicated, but it'd be okay. Attaching to the outside, I would say that's acceptable. We haven't had that. But yeah, that would be acceptable to attach somehow to the external, the outside of the canister. I think bonding would be the approach. I think we don't want to do things that would compromise the structure of the canister wall. So drilling and tapping and bolting to the wall would not be appropriate, but bonding to it would be.
Thanks, John. Okay. For the structural health monitoring of canisters, are you concerned with existing canisters or new canisters or both?
Both.
Great. Second question is, are you interested in robotic inspection, permanently installed sensors, or both?
Both.
This is easy. Thanks, John.
Those are easy so far. Yeah. Yeah, we've
Okay.
looked at both. In both cases, we've
Great.
looked at both.
Thanks so much. We have another one regarding topic 6.4 on impact limiters. Can you comment on the motivation for this particular topic? Put another way, what are the limitations and problems with current impact limiters in terms of their design, manufacturing, performance, etc.?
Well, this is John Orchard again. I'll try to field that question. I haven't been intimately involved with this, but there has been there's a concern that the existing impact limiters, the materials being used are not suitable. And the story I get is the impact limiters have been made of wood, and acquiring enough wood and using wood in that application is not the best. And of course, we haven't built many of these, so the limited number of cases where we've transported used fuel and needed impact limiters, it hasn't been a great concern as to what materials we use. But when we get to the point where we're talking about transporting thousands of canisters, then we're looking for efficiencies and economies in designing these impact limiters. And I think the description of the topic is probably gives you a bit of background in there as to what we're looking for. But I guess the motivation is that we have concerns about the existing material and design, and imagine that there are better designs and materials for the impact limiters. So we're looking for that.
Thanks, John. Another question for topic 6. How important is there's a big one. How important is the manufacturability of components?
Well, this is John Orchard again. It depends what is meant by manufacturability. I mean, obviously, it has to be manufacturable. We're talking about several thousand of these things. So it's not something that needs to be mass produced. So there's an opportunity to have restrictions on the manufacturability. But the costs are some concern. So the less manufacturable they are, the higher the costs are likely to be. But we have to be able to make them. So I don't know.
Hi,
if
John.
that quite answers
John,
the
this is
question.
this is Devin from Oregon State. I'm the one who asked the question. I actually intentionally stated it broadly. But I think the reason I said manufacturability is I'm wondering if there's specific processes that are already in place that you prefer, that these sort of approaches that we match sort of processes that you already have, or if it's open-ended from the manufacturing standpoint.
Oh no, that from that point of view, it's entirely open-ended.
Okay.
I'm not positive what parts you're talking about either, whether you're talking about impact limiters or you're talking about sensors or transmitters, or whether you're talking about the actual canister or whatever.
Right. Sort of
The
all the
actual,
above.
yeah. We haven't been looking at the actual canister or the canister internals, because that's designed and manufactured by the canister suppliers. So that hasn't been high on our list of looking at, if that's what you're talking about. But if you're talking about the parts for, like I say, the sensing or transmitting or other things that we're asking for in this topic area, then that's totally open.
Great. Thank you.
Okay.
Devin, did you get that second part of your question? I know these should be led by universities, but can we form teams with national laboratories and other FFRDCs?
Well, that's a contractual issue, but I think we promote partnering with other entities, particularly national labs. Does somebody from
Great.
contracts want to answer that? Well, let's answer. We promote it.
Okay, great. Thank you. I may ask another question if that's okay. I can just say it.
Yeah, please.
Okay. So, the call is a little bit broad. It's asking for new technologies and to overcome current limitations and problems, like the previous person, Ashley Spear, asked about impact limiters specifically. So, do we need to have a very good understanding of the current limitations and problems specifically with the canisters, or can we just talk broadly about the state of the art for impact limiters, and how specific do you want us to be with that stuff? How deeply do we have to know the canisters, I guess, and their design?
If you're talking about impact limiters, it's I think, yeah, I don't know if it, but you have to know the canister well enough to know what the loads are going to be, the impact loads are going to be. So it's basically a weight issue, and possibly the material strength issue. If you're talking about sensors for what's going on inside the or 3D imaging for what's going on inside the canister, then you have to have a very good idea of what's inside the canister, so you know what you're looking for. So it depends what you're which part you're answering or trying to propose to. The proposal has to have a concrete, I call it a product, but it called, and I guess product's right word. It has to have a concrete solution. So it has to be more than just a general discussion of what an impact limiter is. You have to sort of have a goal of what the material is, what the material strength is, what the design of the impact limiter would be, what its capabilities are, and things like that. So I know, did that answer your question?
Yeah, that was exactly the answer I needed. Thank you.
Okay, good. Thanks.
There's a few more questions in the chat. Is stability of storage casks under external events like earthquakes, wind, etc., a topic of interest?
Yes. It's a big topic of interest. We're doing research on it now. It was a topic last year, I think, that we were specifically looking for. I don't know where in this topic area you could make such a proposal. Sometimes we have a topic, it just says everything else. There is a topic area later, lower, like 9 or 10 or 11 or 12, that is just blue sky. It might fit there, but if you can see in these topics, in this topic area or other topic area where that would fit, you should submit it. But while it's an area of interest to us, it's not listed here. So it'd be difficult to submit a proposal on it. I don't see where it would fit. I'm sorry. Does that help?
Thanks, John. I think it does. I will point out too, we've mentioned in each one of these sessions that if you are unsure of which topic area it might fit in, don't stress too much about that, because the program managers will transfer any proposals they feel fit a better topic area to those program managers. So if you apply to one and it better suits another, we'll make sure that those get into the right spot. So we have another question. Oh, please.
Can I just butt in for a minute? This is John Orchard again. I believe that we go through a preliminary proposal and then the full proposal, right? I think the preliminary proposal is due on June the 6th and the final on July or something.
Yep, pre-applications are due June 26th.
Okay. So the pre-application, I think, is a reduced involvement, so you don't spend a lot of time and effort on making the proposal and figuring out where it belongs. So, and I've forgotten, what is it, 3 pages long or something, the pre-proposal?
5 pages.
5 pages, okay. So, yeah, so do that, submit a pre-proposal. It shouldn't take an over amount of effort compared to a full proposal, and we can try to direct it to the right place. Okay.
All right, thanks, John. Another question for topic 6, area 3. Do we need to monitor cracks only on welds or whole canisters?
We sort of postulate that the cracks are going to develop mostly in the heat affected zone around the welds, and mostly the longitudinal welds and the canister wall. So we're focusing mostly on that area. The weld itself to some extent, but the heat affected zone mostly. The rest of the canister wall is of less concern to us, but the heat affected zones have the sensitivity and stuff and issues there. So generally speaking, if you have a technology that only focuses on that, that would be welcome. If it focuses on the entire canister, that's perfectly acceptable too. And sometimes it's easier to look at the whole canister than at specific locations. So we're open to that.